Okay, indeed, the talk is letting go of control. And the reason I wanted to talk about that is because so much about BPM is about controlling. It's as if the designer is saying, here's all the things you can do, here's exactly how I want you to do it, here's all the branches you can take, just pick one of these choices I've laid out for you. But Jim Siner spoke on Tuesday night about running processes based on agents, and there were two things that stuck with me after the Q&A session. One is that he said that for agents to work effectively, we need to let go of control. So clearly I agree with him on that point. The other thing he said is that the idea that we may predefine and lay out our processes in advance, that idea may go away. And I think that's a really fascinating idea, and I hope to expand on it a little bit. So first of all, what is an agent? We've talked a lot about agents. I've asked a lot of you about agents, and the answer I've gotten back in every case has been the same. Something that does, software that does something for you, it works autonomously, it's directed by goals. But then I point out that just about every piece of software we have fits this criteria. I mean, all software does something for you. A lot of software runs autonomously. It runs in the background, and almost all software has some sort of way to determine when it's finished running. This could be your word processing program laying out your document in the background. It could be your mail server filtering, forwarding email messages. It could be the spam filter that's pulling out spammy messages, or maybe it's the virus scan running on your computer. So the conclusion of this is that agents are already everywhere. In fact, I gather from Denis Gagne that they've been everywhere for about 40 or 50 years now. So in many ways, there's nothing new about it. Yet when we talk about agents, we have this idea of something a little bit better than that. I mean, some people say that agents should act like a person. It should make decisions. It should do something beyond what it was programmed to do. It shouldn't just be a simple, programmable device. So I was thankful that Nathaniel reminded me of this old Apple Knowledge Navigator visionary video where the agent appeared as a little human head, and you actually talked to it, and it would take care of some of the tedious aspects of communicating to other people. It would make appointments for you. It would find out if people were available. It would go find stuff on the web. It would arrange it. It would coordinate things for you. And I think in many ways, what we're looking for is something like this as an agent that helps you coordinate your activities. And so that's what I'll talk about today. But maybe we should call it a personal assistant so that we can distinguish this kind of agent from all of the other agents that are already out there in the world. Before I go too far, let's talk about a concrete scenario that we can use to think about these personal assistants and how they would help you. Now, Alex is a patient, and he has developed a back pain. He goes to visit his primary care physician, and that's Betty. Betty inspects him, runs some tests, determines he needs to talk to a specialist. So refers him to Charles, who is a back specialist. Charles does some more tests, investigates, figures that this problem can probably be solved with physical therapy, and refers him to Dennis, who is a physical therapist. Now, this scenario is important for four basic reasons. One is that we'll always, in medicine, we will always need to go talk to specialists. It'll never be a one-stop shop. There'll always be some expertise that you'll want to tap into. Second is all of these people work for separate companies. If they all work for one company, we could sit down, draw the diagram, they'd all have to live with it, and we'd have it figured out. But because they work for different companies and they have slightly different views on everything, we have to deal with this messiness of what happens when we cross the boundary from one domain to another domain. The third thing is that these people must cooperate, they must coordinate their actions in order to provide good care for Alex. So it's important that they do so. Finally, medical information is sensitive. It's very important that it be handled properly. We don't want to just sort of leave it laying around. It somehow needs to be guarded and securely transferred. So that's why I think this is a good scenario, and I'll be giving a demo of part of this in a moment. Now, we could sit down and say, we're going to draw the big diagram. Somebody who's very important and very powerful will say, you guys are all going to cooperate. We're going to draw this big diagram, and everybody's going to obey it. But that's not a realistic course. The fact is that all of these people have different views on how medicine should be done because of their specialty. But more important than that, medical information is increasing at such a rapid pace that by the time we agree on this process, medicine has probably moved on and there's probably other things to do. So we'll never get agreement among all these people. So what I'm going to talk about today is a way that we can use these personal assistants to work out the differences between these working domains and to get it all to work in runtime. So what if we think about the personal assistant as something that sort of sits in front of a person, it sits in front of you, and it helps to coordinate your communications out to those other domains. Now, I've got different people here. All of the demos we've seen today, correct me if I'm wrong, but have all been inside of a single domain. It's like inside of one company or inside of something. What I'm talking about here is crossing from one domain to another domain. These personal assistants help collect and organize the information that comes back. And I think what we'll find is that these agents will be doing a lot of communicating among themselves, executing rules, executing heuristics, and through all of that extra, allowing us to communicate much more easily to these other people. So that's kind of the goal of these personal assistants. Now what gets really interesting is when you have lots of these, hundreds or thousands of these, then think about it. The process that's in these red arrows in the middle is not scripted in the way that we normally think of as a business process. This is not a collaboration diagram that's been drawn in bpmN, but it's a business process which emerges out of the rules that each of these individuals have set up about how they want to behave. So I thought it'd be good to take a little bit of a look at emergence, an example of emergence, and maybe you've seen this. This is a flock of starlings flying off the coast of England. Each bird is flying on its own behavior. It's controlling its own behavior. But what we see out of this is clearly coordinated action that emerges from it. Now, nobody can say in advance where each bird will fly, but these sort of patterns emerge from it. Now, if I'm drawing an analogy here to your organization where you would have hundreds or thousands of people making their own individual decisions, and yet it's the business that emerges from all of that behavior. Now, if we were to give this to a business analyst, the business analyst would look at the final behavior and say, okay, this is the desired behavior that we want, and then what we're going to try to do is work back to the rules that would bring about this behavior. Well, it turns out that you can do simulations on bird flights, and you find out that birds actually behave fairly simply. There's a small set of rules, avoid hitting each other, stay near the flock, match the velocity of your neighbors. And if you do that, out comes this amazing emergent behavior. But if you look at the emergent behavior, it's very difficult or impossible to learn what the rules are behind it, or at least to derive it in a deductive manner. What you can do is guess at it. That's what we do. We guess it and do forward simulations. A lot of BPM is about trying to come up with those rules, but perhaps we don't need to worry about that so much. Maybe what we instead need is visibility on the emergent behavior, and that's exactly what we saw with Harsh's demonstration this morning. He showed how analytics can give you an overview of what's going on without worrying too much about what the day-to-day daily thing is. Okay, well, anyway. I'm going to switch over to the demo now. I just wanted to mention this is a demo in Cognoscenti. It's an open source project. It's freely available to everybody if you want it. It's not designed as a product, but more as a test bed and a reference implementation for this case exchange protocol for federated case management and for showing this idea of personal assistance. The demo's a little bit complicated. It's a little hard to follow because what I'm going to do is I'm going to go through 4 different sites. And I'm going to show how these different people have their own sites, and they're going to cooperate between them and share information. So let's see if my internet is still working here. First, I'll log in as Alex. Now remember, Alex was the patient. And he has basically a medical care vault, much like eVault. He's got this project here. It's got notes, it's got goals, and it's got a long list of documents. Could be his medical records of various types. If we look at a given document, we'll see that we can make it available to the public or not. We can make it available to the upstream project or not, and then to a set of roles which have been specified. Now, if this was a real health maintenance account, this would probably be quite a bit more sophisticated than this. There'd be more roles, there'd be more options. But for the purpose of showing how a personal assistant works, this will probably do for us. So that's what Alex gets to see. Let's log out as him, and we'll log back in as his personal assistant, his primary care physician, I'm sorry, which is Betty. Now what Betty is going to see is that Betty has a set of projects as well, and she has access to Alex's projects. So let's go over and take a look at it. And the only thing to note here is that she doesn't see the full set of documents. She sees only the documents that have been given access to her. Now, we're not surprised by this. Everybody in this room knows how access control works. I just wanted to show that this environment, takes care of access control and allows Alex to control who can see what. Now, Betty can't actually do any work in Alex's, so she's got her own project here, which is a project which is Betty's view of Alex, and this is actually a clone of Alex's project. So if we look here, we'll see the same 4 documents. These have been copied over. Okay, so if the idea of copying the documents to a separate project makes you uncomfortable, we do have a Q&A section at the end. Think about what questions you want to ask. So they've been copied here, but by having a separate project, Betty can then bring her staff in, can make these available to her staff. She has some control over the access on this, and can assign goals to 2 different people. Now, I mentioned that Betty talks to Alex, decides that he needs to see a specialist. So what I'm going to do is we'll do that by saying, we're going to create a goal right now, investigate back problem. And I'm going to assign this to Charles. So we don't focus on the communications to Charles, but we focus on the job that Charles is going to do and who's going to do it. And we let the system do the notification back and forth. So now I've got a task here assigned to Charles, and through this, Charles will be notified. So at that, let's switch people again and take a look and see what Charles would see. Now, I think I forgot to mention that Alex and Betty are hosted on a server in the cloud. Charles is actually hosted on a server that I'm running here on the laptop. And that's important because this is not just one site that they're looking at information. We're actually going to move information from site to site. So let's see if I can log in as Charles here. And so we see that Charles has a set of projects as well. None of these projects has anything to do with Alex at this point, and we'll change that in a moment. But let's take a look at what his goals are. We'll take a look at his remote profiles. Now, a remote profile is a remote place where you can pick up tasks that are assigned to you. So this would come in that notification message would come some sort of a link which would set up this remote profile. If I go look at his goals, he has no goals, he has no tasks assigned to him at the moment, but by clicking this refresh button, it's going out with a web service, a REST-oriented web service call, and bringing it in. And so good enough. The task has appeared here that I just assigned, investigate back problems. I can click on this, see some details about it. I see that it's actually located at Betty's site, a separate system. I can reach out to that system and take a look at the goal on that system, and perhaps if it was that kind of a task, complete it right here. But it's not that kind of a task. I can also go down here and create a clone of the project, decide where I want that clone to be, and then I set up a little bit of information. By creating a clone, it's going to copy all of the context from that other project, which could be a BPM process, it could be just a case, management case, whatever it is, doesn't matter. It'll bring it in here and allow me to do my stuff and bring my processes in to bear on that. Now, I don't want to manually create this clone because this talk is about personal assistance. So let's talk about what he's set up here. So this is the definition of his personal assistant, and I've got 4 rules in here that will do various things for Charles automatically. Of course, in this demo, I'm doing it all manually, but so that you can see what goes on. And this is a very simple rule-based assistant agent, if you will. I think we saw a much better demonstration of that a couple of talks ago when Dominic showed his intelligent process controller. It's that sort of thing, but here we're simulating it simply with a set of rules. When those rules are satisfied, there's a set of actions you can do, like going out to the other system and accepting the task, or automatically cloning the project. Here's where the project will be cloned to, and here's where you select a template. The template has a process in it. So every time I see a task of this sort, I'm gonna automatically clone it to my environment and invoke a process, which is then gonna run and do what I wanna do. So let's see how this works. Go back to the personal assistants. I'm gonna manually run this at this point on the tasks which have been gathered through basically the workcast protocol. It has now created this clone of the project that was on Betty's site. It has brought all of those documents down. It's copied them down for me. And these are now synchronized. If I was to add a document here, it would be automatically synchronized back to Betty, depending on how I set that access control. Also, it has brought in a process here, which these are the kinds of things I typically do what Charles does when he gets assigned a task about the back. And he'll go ahead and start, start the set up the appointment, and we'll start the review the X-ray and review the MRI, and I'm gonna create another goal right here, which is, let's do a strength test. Just on the fly, if a new technique has come up, I can bring that in and ask for that goal to be done. I'm going to drag that up here to the top because it's a law in the BPM conferences that you have to say drag and drop at least once in your presentation. So I've now done that, and I can also say no coding was required. So good enough. He works. This project may persist for a long time. He determines that physical therapy is the right approach to that. So he goes down to the therapy thing, and he's going to start that, and he's going to assign it to Dennis. And again, by assigning it to Dennis, a notification goes out. Dennis may, in fact, go and clone this project there and do the work there. So that's essentially oh no, there's one more part of the demo, which is I wanted to show that in the documents here, we've got 4 documents. If he wants to add, if he's got a conclusion of the testing that he's done and why he came up to that answer, he could choose a file, add it to the list of documents here. And so now it's added to the local project, and then through synchronization, and synchronization would be automatic, but through synchronization, what I can do is control whether or not this should be synchronized up, and I could give it to different roles that exist here. And then when we look at synchronization, we'll see that there's a document that needs to be synchronized back to Betty. So the workspaces are kept in sync. We have information flow. So there's a couple of conclusions that we can make from this demo. First is notice that your personal assistant, even though these are very, very simple personal assistants, these have helped to improve the communications between the parties in this scenario. And I think some of the more sophisticated personal assistants would go even further. What's different about what I'm showing here is that there's a my sandbox and a your sandbox, and we're using the assistant to reach out and manipulate things in the other sandbox, and that's important. Second thing is this is safer than email. Okay, it's better than email. If you send a document by email, it goes into someone's inbox, right? And of course, hopefully they guard the security around that, but that's up to them to manually do. What I demonstrated here, no document went through email. It all went through an encrypted SSL channel from an access-controlled environment into another access-controlled environment. So it's very easy to safeguard this information and yet still distribute it around. A little bit of a recap of the demo. You could sort of see this as the primary doctor assigning something to the back specialist, but what we really did was we had the back specialist's personal assistant step in and act as an agent on that doctor's behalf and act in some ways like a person to that other process. Then the personal assistant cloned the project brought in some processes locally that Charles wants to use, and also brought the data down and kept it in sync in the long run. So this is, I think, a specific, realizable goal. Not quite as easy as it seems, because there is this fan-out effect. If we were just to design this as a process, you'd see this as a sub-process invocation. But the fact is there's many primary doctors, many back specialists, many physical therapists. We only investigated one combination, but you need to be prepared to handle all of them. So when you do this cloning, when you do this bringing of the data, there needs to be a little bit of manipulation of the data, normalizing of the data, because we understand these different people are naturally going to have some differences. We can standardize things as much as we want, but there will always be some specialization going on. And the way we can do that is with some form of semantic mapping, some form of ontology that backs up this data. The personal assistant uses that ontology and translates the data as it synchronizes in both directions. So in summary, this is a vision of personal assistance which can help improve the communications between people. It can receive and screen notifications, filter out the spam. It can do what we call task introduction, which is it can discover the task and gather information about it. It can accept the task. It can clone the project for you. It can determine what template to use. It can synchronize the data in both directions. And it can transform the data according to ontologies and according to semantic information about the data. And that's it. In the future, we might see personal assistants interacting with other personal assistants, cloning and synchronizing projects, and the large-scale process emerging from that interaction. Thank you.